Good day. The topic we are treating today is proportion, and it's going to be basically on reciprocal. We've talked about what direct proportion is. So this reciprocal is just a topic one must know before we can move to the topic indirect proportion. So you must know what reciprocal is for you to understand what indirect proportion is. By Okola Nosirat Olajumoke. So the objective of this lesson is to know what reciprocal is and also find the reciprocal of numbers. It can be fractions, it can be decimal numbers, and so on. So that by the end of the lesson, you know what reciprocal is, and also you'll be able to find the reciprocal of numbers and apply this knowledge in the topic indirect proportion. So the topics you must have known before you can watch this video. The topics are division of numbers. You must know how to divide numbers. Indices. There are some rules of indices that are applied here. Decimal places, that is how to reduce number to a particular decimal place or significant figure. So these are the things you must have known before you can watch this video for better understanding. So now move to the main topic, reciprocal. What is reciprocal? When you multiply two numbers together and the result equals 1, then one number is a reciprocal, or it is also called multiplicative inverse of the other, or vice versa. If you multiply 2 and half together, the result will be 1. That means 2 is a reciprocal of half, and also half is a reciprocal of 2. Reciprocal can also be called multiplicative inverse. So when the product of two numbers gives an identity, an identity for multiplication is 1, but the identity for addition is 0. But here we are talking about reciprocal, so we are dealing with products. So when the product of two numbers gives an identity, that is 1, then one number is a reciprocal, or you can also call it multiplicative inverse of the other, or vice versa. That is, if A and B are two numbers and you multiply them together and the result gives 1, then A equals to what? 1 over B, that is making A the sort of formula, or B equals 1 over A. What this statement is trying to say is that A is a reciprocal of B, that is, whenever you want to find reciprocal of a number, is going to be 1 divided by that number, and B is the reciprocal of A. When you want to find the reciprocal of A, reciprocal of A is 1 over A, which is B here, since we are multiplying B by A, and the reciprocal of B, which is A here, but it is divided by what? 1 over B. I said the reciprocal of B will be A, but if you want to find the value of A here, that is making A sort of formula, is going to be what? 1 over B, and then reciprocal of A is B, which is 1 over A. So what this means is that if you want to find the reciprocal of a number, it's going to be 1 divided by that number. You divide 1 by that number you are to obtain its reciprocal. So that is A reciprocal of B, or vice versa. Vice versa means or B is also a reciprocal of A. So there are some hints given here, and this is the only rule of indices that you apply here. 10 raised to power minus n equals to 1 over 10 raised to power n. This is one of the rules of indices, which you are going to need very much when you are dealing with reciprocal. And also, you must know how to convert decimal to standard form. I think that is a primary school thing, how to convert a decimal number to its standard form. This is 0.45. What you do is you write these numbers as a whole number, and then you count the numbers that are after the decimal point. We have two numbers after the decimal point. That is why we have times 10 raised to power. Since it is 0 points, so that is raised to power minus 2. Assuming we have 4500, we have 45 times 10 raised to the power 2, since we don't have a decimal point. That's like 4,500 is like 45 times 10 raised to the power 2. I know that 10 raised to the power 2 is equals to what? 10 multiplied by 10. That's 45 times 100, which will give 4,500. But here, if we want to convert 0.45 to a standard form, it's going to be what? 45. How many numbers are after the decimal point? We have 1, 2. Since it is a decimal point, since we have a decimal point here, it is a decimal number, so that's why we introduce minus, and the numbers after the decimal point is 2. And we already told that 10 raised to the power minus n is equals to what? 1 over 10 raised to the power n, which is the same thing you are going to apply here. 10 raised to the power minus n equals 1 over 10 raised to the power n. So 10 raised to the power minus 2 will be what? 1 over 10 raised to the power 2. This is what this statement changes to. 45 times 10 raised to the power minus 2 equals 45 times 1 over 10 raised to the power 2, which is 45 times, what is 10 raised to the power 2? 10 multiplied by 10, and 10 multiplied by 10 will give 100. That is why we have 45 times 1 over 100. So 45 times 1 over 100 is what? 45 over 100. So I'm just trying to revise how one can convert a decimal to a standard form and also get the answer in a fraction. This is the decimal, this is the standard form, and this is the fractional form of 0.45. So now those are the hints you need for this particular lesson. Now we move to examples. We have 4 examples in all. So the first example says we should obtain the reciprocal of 8 and 4.5. The second example says if the reciprocal of 25 is 0.04, if you check the reciprocal of 25, you see that it's also 0.04. We have to find the reciprocal of 0.025 and the reciprocal of 2,500. So using long division, you know what long division is? We have to find the reciprocal of 0.5. So long division means we will not use calculator. You show your workings how you obtain the reciprocal of 0.52. So we are also to find the reciprocal of these two numbers, leaving your answers in 3 decimal places. So this is when you need your knowledge of how to reduce numbers to decimal places or significant figures. So now we move to the solutions of these examples. So the first example, we are told to obtain the reciprocal of 8, and I told you if you are to obtain the reciprocal of any number, it's going to be what? 1 divided by that number. So the reciprocal of 8 is what? 1 over 8, and when you convert 1 over 8 to fraction, it's going to be what? 0.125. You can use a calculator for that. 1 over 8 will give 0.125. So the second question says we should obtain the reciprocal of 4.5. 4.5 is a decimal. We can change it to its fractional form. So 4.5 is, we first write down 4 and 5 as the whole number, which is 45. How many number is, so 4.5 will be what? 45. So this and this will be a whole number times what? How many number do we have after the decimal point? 1. That's why we have 10 raised to the power minus 1. And from the int, we are told that 10 raised to the power minus n equals to 1 over 10 raised to the power n. So we have 45 times 1 over 10 raised to the power 1. And you know that 10 raised to the power 1 is also equals to 10, which is what? 45 times 1 over 10. And 45 times 1 over 10 will give 45 over 10. So the fractional form of 4.5 is what? 45 over 10. So the reciprocal of 4.5, I told you that the reciprocal of a particular number is 1 divided by that number. What we did here is just changing 4.5 to its fractional form, which is 45 over 10. After then, we now answer the question by obtaining the reciprocal of 4.5. So the reciprocal of 4.5 is 1 divided by 4.5, which is, what is 4.5 in its fractional form? 45 over 10. So this statement can change to 1 divided by 45 over 10. And this is the statement in full. 1 divided by 45 over 10. And you already know from primary school, if you want to change the division to multiplication, the denominator will become the numerator and the numerator will become the denominator. That is why we have 1 multiplied by 10 over 45, which is what we have here, which is equals to what? 10 over 45, which can also be given in its lowest term. If you use 5 to divide the numerator, you get 2, and also 5 to divide the denominator, you have 9. So the lowest form of 10 over 45 is 2 over 9. Therefore, the reciprocal of 4.5 is what? 2 over 9, because it's always good to write your answer in the lowest form. So that is the reciprocal of 4.5. Now we'll move to the second question. We were told that if the reciprocal of 25 is 0.04, then what is the reciprocal of 0.025 and 2,500? So the reciprocal of 25 is 0.04, that is 1 over 20. You know, the reciprocal of 25 is 1 divided by 25, which has been given as 0.04. So the first thing you have to do is what? We should find the reciprocal of 0.025. The first thing you do is use the int to obtain the fractional form of 0.025. So what are we going to do? It's going to be 25 multiplied by, how many numbers do we have after the decimal point? We have 3 numbers. That's going to be 10 raised to the power minus 3, and that will be what? 25 multiplied by, so that's going to be 25 multiplied by 1 over 10 raised to the power 3, and you know 10 raised to the power 3 is 10 multiplied by 10 multiplied by 10, which will be 25 multiplied by 1 over 1000, and 25 multiplied by 1 over 1000 is 25 over 1000, which is what we have here. So that is an exercise for you to just try and see if you can use the int given to obtain that the fractional form of 0.025 is what? 25 over 1000. You know, it has been explained in the first 2 examples when we converted 0.45 to its fractional form, and we converted 4.45 to its fractional form. So you can just try, if you can just do this. You find the fractional form of 0.025 and see if you get it as 25 over 1000. So that is just a challenge for you. So now we already have the fractional form of 0.025 to be 25 over 1000. Now we are to obtain the reciprocal of 0.025. So the reciprocal of 0.025 will be 1 divided by 0.025, and you already know the fractional form of 0.025 to be what? 25 over 1000. So this is something as saying 1 divided by 25 divided by 1000. So this statement is written in full here, 1 divided by 25 over 1000. And you know, when you want to convert your division sign here to multiplication, the numerator will change to the denominator and the denominator will change to the numerator, and that is what we have here, which is equals to 1 multiplied by the denominator will change to the numerator, which is 1000 over 25. And you know that this can also be written as 1 over 25 multiplied by 1000. You know, this is a numerator for all. It can be changed to 1 over 25 multiplied by 1000. So, and we already know the reciprocal of 1 over 25. You know, the reciprocal of 25 is 1 over 25, and we are told that it is 0.04. So we don't need a calculator for this. We already know that the reciprocal of 25, which is 1 over 25, is 0.04. That's why we have 0.04 here multiplied by 1000. So 0.04 multiplied by 1000 will give 0.04 divided by 1000 will give 40. Therefore, the reciprocal of 0.025 is what? 40. So that is the first question. That's the first part of the second question. So the second part says we should obtain the reciprocal of 2500. And you know that the reciprocal of 2500 is what? 1 over 2500. And this can be split. You know that 1 over 25 times 1 over 100 will also give 1 over 2500. The reason why we split it is that, you know, we have been given the value for the reciprocal of 25, which is 1 over 25 as 0.024. So we want to bring out 1 over 25 in one side, then the remaining at the other side. So since 1 over 2500 can be splitted to 1 over 25 multiplied by 1000, 1 over 100. For us to use that value given at the beginning of the question, we were given a particular value in the question that the reciprocal of 25, which is 1 over 25, is 0.04. So we are to use that value to obtain the reciprocal of 2500. I know that the reciprocal of 2500 is 1 over 2500. And 1 over 2500 can be splitted as 1 over 25, which is what we have been given already, multiplied by 1 over 100. If you do this, you will get 1 over 2500 back. And from the question, we've been given the value of 1 over 25 to be 0.04 multiplied by 1 over 100. You convert this to its fractional form. You know how to do that. It's going to be what? 4 multiplied by 10 raised to the power minus 2. We have two numbers after the decimal point. That's 4. 0, 4 is same thing as writing 4 alone. How many numbers do we have after the decimal point? We have two numbers. That's why we have multiplied by 10 raised to the power minus 2. And 4 multiplied by 10 raised to the power minus 2 is same thing as saying 4 multiplied by 1 over 10 raised to the power 2. And 1 over 10 raised to the power 2 is same thing as saying 1 over 100. So 4 multiplied by 1 over 100 is what? 4 over 100 multiplied by this 1 over 100 here. So 4 multiplied by 1 will give 4. 100 multiplied by 100 will give 10,000. Or you change it to a decimal form as 0.0004. I know that if you want to convert this to its fractional form, assuming you don't know it is 4 over 10,000, you are given 0.004. You have 4 multiplied by how many numbers after the decimal point? That's 10 raised to the power minus 4. 4 multiplied by 1 over 10 raised to the power 4. 4 multiplied by 1 over 10 multiplied by 10 multiplied by 10 multiplied by 10, which will give 10,000, and you have your 4. And you have your 4 over 10,000 back. So therefore, the reciprocal of 2500 is what? 0.0004. And that solves the question. Now we move to the third question. The third question asks us to use long division to obtain the reciprocal of 0.52. We are given such a thing. You know that the first thing to do is you convert 0.52 to its fractional form, which is 52 over 100. We have 50. How many numbers after the decimal point? Since it is 0 point, you know that it will be divided by 10 raised to the power 2. That's why we have 52 over 100. So the reciprocal of 0.52 is what? 1 divided by 0.52. The first thing we did here is not reciprocal. We only converted 0.52 to its fractional form. After that, you will obtain the reciprocal of 0.52, which is 1 over 0.52. So you can rewrite 0.52 in its fractional form as 1 divided by 52 over 100. And this is the statement, 1 divided by 52 over 100. You change this to multiplication sign, and whenever you do that, your denominator becomes your numerator and your numerator becomes your denominator, and that is what we have here. So 1 multiplied by 100 over 52 is 100 over 52. But the question says, do not use calculator, use your long division method. So this is the long division method. The numerator will be inside, the denominator will be outside. So how many times can you see 52 in 100? We can only see it once. So that's why we write 1. 52 multiplied by 1 will give 52. You subtract 52 from 100, you have 48. 48 is less than 52. So it is impossible to divide 52 by 48. So how many 52 can we see in 48? That is impossible, because 48 is less than 52. So we have a decimal point here. So whenever you put your decimal point here, you add 0 to 48 to make it 480. I think this is just the primary school work. The long division thing is a primary school work. So 52 divided by 480. How many 52 can we see in 480? If you use your calculator very well, you see that it's going to be 9. 9 will be the whole number. Though we have some decimal points, but the whole number is going to be 9. So you do 52 multiplied by 9, you get 468. You subtract 468 from 480, you have 12. You can't see 12 is also less than 52. So you had 0 to 12. Since we already have a decimal number here, you can't put another decimal number after 9 again. All this are decimal. This is the only whole number we have. So since 12 is also less than 52, you add 0 to the back of 12, making 120. How many 52s can you see in 120? We can see just 2 with remainders, but 2 will be the whole number. 2 multiplied by 52, we have 104. So you subtract 104 from 120, it's going to give you 16. 16 is also less than 52. You add 0 to the back of 16, we have 160. How many 52s can you see in 160? We can see just 3. 3 multiplied by 52 is going to be 156. You subtract 156 from 160, you have ordinary 4. 4 is far less than 52, so you add 0, making 40. 40 is also less than 52, you add another 0, making 400. These zeros you are adding is because we already have a decimal point here. That's why we can add 0 to its back. So we don't need to put decimal points. Since we have a decimal point here, we all know that all these sides are the fractional part, and this is the only whole number we have. So how many 52 can we see in 400? We can see 7. 7 multiplied by 52 we give 364, and if we subtract 364 from 400, we have 36. 36 is less than 52, so we add 0 to the back of 36, making 360. How many 52 can we see in 360? That we have 5 52s. 52 multiply How many 52 can we see in 360? We can see 6. 6 multiplied by 52 is going to be 312. You subtract 312 from 360, you have 48. And you know that this is like it's beginning to repeat itself because we already have a 48 here again. If we should start again, we start from 9 2 3 7 6 9. So 9 2 3 7 6 will be repeating itself. So it's better we stop here. The reason why we stop is that we have 480 here. We'll check for the number of time 52, a number of time we can see 52 in 480. That will be 9 again. 9 multiplied by 52, we have 468. We begin this process all over again, and that is like these fractional parts will be repeating themselves. So we stop here. So 9 will truncate the division here. So this implies that 100 over 52 is 1.5236. I know that 100 over 52 is the reciprocal of 0.52. Therefore, the reciprocal of 0.52 is what? 1.92376. And that solves the question. Now we move to the fourth question that says we should obtain the reciprocal of obtain the reciprocal of 1.4 and 5 over 6 to 3 decimal places. So, and you know that if you want to convert 1.4 to its fractional form, it's going to be 14 times 10 raised to the power minus 1, which is something as 14 times 1 over 10 raised to the power minus 1, which is 14 times 1 over 10, which will be what? 14 over 10. So the reciprocal of 1.4 is what? 1 divided by 1.4, which is something as saying that 1 divided by what? 14 over 10. And this is the statement, 1 divided by 14 over 10. You change this to multiplication. Your denominator becomes your numerator, and your numerator becomes your denominator, which is going to be 1 multiplied by 10 over 14. And 1 multiplied by 10 over 14 is what? 10 over 14. So you can change this to a decimal form, which is 0.7142857142. So we are asked to change this decimal form to 3 decimal places. That is 3 number. You stop your answer at 3 numbers after the decimal point. So after the decimal point, this is 1 2 3. So you stop your answer at 4 here. So one thing is how to approximate. You know, in approximation, if you see any number after that number, you have to stop. If the number is between 0 to 4, you approximate it as 0. But if the number is between 5 to 9, you approximate it as 1. But here we can see that the number after 4 is 2, and it is between 0 and 4, so it approximates it to 0. So here 2 will become 0, 0 plus 4 will also give us 4. So therefore the reciprocal of 1.4 is 0.714 to 3 decimal places. So the next one says we should obtain the reciprocal of 5/6. And the reciprocal of 5/6, as we all know, is what? 1 divided by 5/6, which is the statement 1 divided by 5/6. You change this to multiplication, it's going to be 1 multiplied by what? 6/5, when your denominator has changed to your numerator, and your numerator has changed to your denominator. And 1 multiplied by 6/5 is what? 6/5. If you change this to decimal form, you have 1.20000. I know zeros after decimal point is useless. So to 3 decimal places, what? Here you stop here. This is the first number after the decimal point, second number after the decimal point, third number after the decimal point. I know 0 is between 0 here is the number after the last number where you are supposed to stop, and it's between 0 to 4, so you consider it as 0, which is the last number here, plus 0 that you converted this 0 to, is going to be 0. So we have 1.200 to 3 decimal places. Therefore the reciprocal of 5/6 to 3 decimal places is 1.200. It can also be written as 1.2 because zeros after the decimal point is useless. So those are the answers to the questions. So these are exercises for you to solve, to check if you understood what we have been discussing. So the first number asks us to find the reciprocal of some numbers, leaving your answer to 3 decimal places as you have been taught. The first number is 1.7, the second number is 502, and third number is 8/9. The second question says you should obtain the reciprocal of 1.57 using long division method, and you should leave your answer to 4 significant figures. The third question says if the reciprocal of 4.21 is this and the reciprocal of 5.16 is this, we should obtain the reciprocal of the following: 0.0421. You can see that this first question is relating to this and this second question is relating to this. So next video will also be more on proportion. That is when we are going to talk about the indirect proportion, and you are going to need the idea of reciprocal in knowing what indirect proportion is and solving questions on indirect proportion. So next video will be more on proportion with sample questions and solution. Thanks.